When graphing the tangent, we want to figure out if we have amplitude changes, if we have a phase shift, if our period is different, or if we have a vertical shift. So we want to identify A, B, C, and D. Our amplitude is the absolute value of A, which is 4. Our period is pi over B, or pi over 2, which simplifies to the number 2, no pi. Our phase shift is C over pi over 2, or 0 over pi over 2, which is 0, meaning I'm not shifting it left or right. And our vertical shift D is 0, which means I'm not shifting it up and down. Now, in order to find the interval in which tangent is going to give us a full cycle, we're going to solve the inside function bx minus c between negative pi over 2 and pi over 2. I'm going to divide through by pi over 2. Which is negative 1 is less than x is less than 1. So we're going to get a full cycle from negative 1 to 1, which is where our asymptotes are going to be. I'm going to go ahead and add for more cycles. Tangent normally goes through the point 0, 0. Because I am not phase shifting or vertically shifting, it's still going to go through the point 0, 0. I have an amplitude of 4, which means my graph is going to be stretched vertically by a factor of 4. But let's find 2 points on either side of that middle point, that midpoint, to find values. So I'm going to find the function at a half and the function at negative 1/2. Substituting in 1/2, I have 4 times tangent pi over 2 times 1 over 2. Pi over 2 times 1 over 2 is pi over 4. Check in my unit circle. I see that the tangent of pi over 4 is 1, and 4 times 1 is 4. So I have the point 1/2, 4. Using the same idea for f of negative 1/2. I have the function at negative 1/2 is equal to 4 times the tangent of negative pi over 4, and the tangent at negative pi over 4 is negative 1. So f at negative 1/2 is negative 4. And then I create my rough sketch of the super skinny tangent function here. Finishing up, graphing y equals the cotangent of x plus pi over 2 minus 3, we need to figure out the amplitude, the period, the phase shift, and the vertical shift. So let's identify A, B, C, and D. The amplitude is the absolute value of A, or 1. The period is pi over B, or pi. The phase shift is C over B, or negative pi over 2 over 1, or negative pi over 2. And the vertical shift is D, which is negative 3. So I'm going to be going to the left pi over 2 and down 3. Normally, our cotangent is similar to our tangent, but it doesn't go through 0, 0. It goes through pi over 2, 0. We're going to use the inner part of the function, bx minus c, in between 0 and pi to figure out what the full cycle interval is going to be. Subtracting pi over 2, we get negative pi over 2 is less than x is less than pi over 2. So our interval is going to go from negative pi over 2 to pi over 2, which is where our asymptotes are also going to be. And like I said, normally you would go through the point that's pi over 2, 0, but you're going to shift it pi over 2 left and down 3 to get your new point. That's your phase shift and your vertical shift together. Now we want to find 2 points, just like we did with tangent. I'm going to pick to the right of 0 and to the left of 0, and halfway between 0 and pi over 2 is pi over 4. So let's find the function at pi over 4. That's going to be the cotangent of pi over 4 plus pi over 2 minus 3, which is the cotangent of 3 pi over 4 minus 3. The cotangent of 3 pi over 4 is the reciprocal of tangent, which is -1. We have -1 minus 3, or the function at pi over 4 is equal to -4. Same thing for negative pi over 4. That's the cotangent of negative pi over 4 plus pi over 2 minus 3, which is the cotangent of pi over 4 minus 3. The cotangent of pi over 4 is the reciprocal of tangent at pi over 4, which is 1, which is also 1, so the cotangent is 1. Then 1 minus 3 is -2. So f of negative pi over 4 is -2. And then we sketch our cotangent function. And that's it for this section.